Diffraction. So what is the definition of diffraction? Diffraction definition: the bending of light waves around the edges of an obstacle, that is called diffraction. The bending of light around the edges of obstacle or aperture, that is called diffraction. The diffraction is divided into two types of diffraction. So these are two types. Number one, Fresnel's diffraction, and number two, Fraunhofer's diffraction. So Fresnel diffraction and Fraunhofer diffraction. Fresnel and Fraunhofer diffraction. So what is Fresnel diffraction? What is Fresnel diffraction definition? For example, this is the source. The source and screen. This is the obstacle or aperture. Obstacle or aperture. What is the definition of Fresnel's diffraction? Fresnel's diffraction. So what is the definition of Fresnel's diffraction? The source and the screen. The source and the screen are placed at particular distance, that is finite distance from the aperture is called Fresnel diffraction. The source and screen placed at a particular distance from the slit or from the aperture, that is called Fresnel diffraction. So this is at a distance of finite distance. If the source and this screen is placed at a distance of infinity distance, so placed at a distance of, the source and screen are placed at a infinity distance, that is called Fraunhofer diffraction. You can see on the screen. What is diffraction? What are the types of Fresnel diffraction? So diffraction, the bending of light. You see here the bending of light waves around an obstacle and deviation from a rectilinear path is called diffraction. Simple definition, simply remember, the bending of light waves around an aperture or obstacle is called diffraction. That's all. Diffraction. So condition for diffraction: the size of the aperture or obstacle is comparable to the wavelength of light, nearly equal. So the size of the obstacle is comparable to the wavelength of light. So diffraction is divided into two types. Number one is Fresnel diffraction and number two is Fraunhofer's diffraction. So Fresnel's diffraction definition already I discussed. So Fresnel diffraction definition: the source and the screen are effectively at a finite distance, at a particular distance. These are placed, the source and screen are placed at a particular distance, that is called particular distance from the obstacle or aperture, that is called Fresnel's diffraction. You have studied in your intermediate. But Fraunhofer's diffraction, the source of light and the screen are placed at infinity distance from the obstacle or aperture is called Fraunhofer's diffraction. So second point, you see here, second point. What is that second point? The incident wave front. The incident wave fronts are either spherical or cylindrical. The wave fronts used is either spherical or cylindrical. You can write in your own words. So spherical wave or cylindrical wave is used in Fresnel's diffraction. Fresnel's diffraction. Second point, in Fraunhofer diffraction, a plane wave means this is the plane. So if we take W dash is the plane wave. So wavefront used is plane. In Fraunhofer's diffraction, plane wave front is used. So no need of lenses in Fresnel diffraction. So lenses are not necessary to study the diffraction in Fresnel diffraction. It can be observed directly on the screen without the help of any lens or any mirror. That is the third point. What I am saying, third point, it can be observed directly on the screen without the help of any lenses or mirrors. So there is no use of lenses in the Fresnel diffraction. Fraunhofer diffraction, the incoming light is made parallel with the help of a lens, and the diffracted beam is focused on the screen using another lens. So simply you can write like this: lenses are necessary to study the diffraction pattern in Fraunhofer diffraction. For example, this is the source, light source. The light rays are moving in all the directions. So if we take one convex lens, these rays are incident on the convex lens. These are giving parallel or plane waves, we can see. So parallel or plane waves we can observe here, parallel or plane. Last point, you see here, last point, it is observed at a point on the screen. The Fresnel's diffraction we can observe at a point on the screen. In Fraunhofer diffraction, we can observe in a given direction, in a region, particular region. The bright fringe and dark fringes we can be observed in a particular region. That is the Fraunhofer's diffraction.